What we're looking at in this lesson is a little introduction to algebraic modeling. So first off, what exactly is an algebraic model? Well, as you can see right here, an algebraic model is an algebraic expression or an equation which is used to represent some sort of a situation. So it could be an expression in that it just has a series of terms. Let's fix this here. Move that back up. Use this. So if it's an algebraic expression, it's just a series of terms. Or it could actually be an equation. Now, how would you know that it's an equation as opposed to an expression? What's the difference between the two of these things? What does an equation have that an expression doesn't have? It has that equal sign in it. Absolutely right. Something on one side equals something on the other side. Okay? So the way we create an algebraic model is we use what's called a let statement. And we always want to choose a variable that is going to represent something that we don't know in our question. Okay? There's always something we're trying to find. We don't know what it is, but we choose a variable to represent it. So here are some examples of let statements. Let x represent the unknown number. This assumes that we're trying to find some sort of a number here. We could be trying to find the cost of a book, in which case we would choose c to be our variable, and we would let c represent the cost of the book. Or maybe we're trying to find Kate's age. We could use k as our variable to represent Kate's age. So let's do a few examples here where we just sort of create this algebraic model. Okay? So our first example here, one number is double another number. Okay? What are we trying to find in this example? Well, we're probably trying to find what these numbers are. So what we can say is, let x represent, let's try that again, let x represent one number. We've got two numbers in this question. We're going to let x represent one of them. Now, what about the other number? Well, how are these two numbers related? We know that the other number is double the one, our first number here. So if we see double, what operation are we doing between our two numbers here? We are doing addition, subtraction, multiplication, division. What do you think, Jackie? Multiplication. Multiplication by 2. So the other number would be 2x, double that first number. So 2x is the other. So now we have expressions, x and 2x, for our two numbers. If our first number is x, our second one is 2x.
And it says one number is double another number. The first number is double the second.
Okay. One number is double. In this case, it doesn't really matter which one you choose as the first number and which one you choose as the second number. Okay? So let's say, if we could clarify this to say, let's see, one number is double another number. So let x represent the second number. Okay, that would be this one right here. And 2x is the first number. Does that make more sense? Okay. Same sort of thing here. One number is 1/3 of another number. Okay? We can again start the same thing. Let x be one of the numbers. Okay? What is the other number going to be? If it is 1/3 of the number that we've chosen to be x. We see that 1/3, what operation are we thinking about here? What are we going to divide by? Yeah, so x divided by 3 would be the other number. Okay? One number is 7 more than a number. Okay? Let x be one number. Okay? So x is one number. This one number is 7 more than another number. So what kind of expression can we have for the second number? Now, is it going to be x plus 7? Let's think about this. X plus 7 is the other. So if it's x plus 7, this second number here is going to be 7 more than our first number. So we actually want this to be, yeah, x minus 7. We want that first number, one number, is 7 more than this one. So this one has to be 7 less than the first number. Two consecutive odd numbers. Okay, now we're getting even less and less information here, but we can always start this the same way. Let x be the first number. Okay. Now, what does it mean by consecutive odd numbers? Well, odd numbers are going to be things like 3, 5, 7, 9. Okay. Consecutive just means that they are next to each other. So 3 and 5 are consecutive odd numbers. 5 and 7 are consecutive odd numbers. 7 and 9 are consecutive odd numbers because they're one after another. If x is my first one, how do I get to my second number? Like, let's say I'm starting at 3. What would an expression be that would get me to 5? What kind of operation do I have to do? Yeah, I have to add 2. So if the first one is x, x plus 2 is the second. And I have to add 2, so I skip over that even number in between. Okay? All right. Josh is 5 years younger than Becky. Okay. Well, now we're getting to closer to sort of real-life situations here. So we're going to choose, let's see, we need a variable to represent either Josh's age or Becky's age. Which one do you want to do first here? Gabriella? Who should we choose, Josh or Becky? Okay. And what letter do you think we should choose to represent Josh's age? J. So let J be Josh's age. If Josh is 5 years younger than Becky, and J is Josh's age, what's an expression for Becky's age? What do you think here? Dante? J minus 5. Okay? So that would mean that we would take Josh's age, subtract 5, and then we would get Becky's age. So that would mean that Becky's age is smaller than Josh's age. Is that true? Yeah, it's got to be the other way around. Okay? Becky is older than Josh is, so we have to add 5 to Josh's age to get Becky's age. Okay? A trickier one here. The length is 5 more than triple the width. So let's just pick a variable here. Now, they're saying, we sort of look at how this is phrased here. The length is 5 more than triple the width. So we should choose width here to be our first variable. So we'll let W be the width. Okay. If our length is 5 more than triple the width, we can come up with an expression for the length. The length is going to be what? What do we need to do to that W if the length is 5 more than triple the width? Well, if we see triple, what operation are we doing when we triple something? Addition, subtraction, multiplication, or division here? Multiplication. So we got to multiply by 3, so 3W. And if we've got this 5 more here, what operation are we doing? Addition, subtraction, multiplication, or division. Of how much? So we got to add 5. So the length is 5 more plus 5, then triple the width, then 3 times the width. Okay. And let's see. We'll try this next one here. The total number of dogs and cats is 40. Okay. Well, we've got dogs, we've got cats. We'll pick one of these here. Let D be the number, the number of cats, let's say. Well, that's backwards. If I chose D, I don't want that to represent cats. I want it to represent dogs, because it's really confusing if I use D to represent cats. So let D represent the number of dogs. What would be the number of cats? Whoops, the number of cats. Okay. So if the number of dogs and the number of cats have to add up to 40, and we've chosen D to be the number of dogs, how can we figure out how many cats there are going to be here? 40 minus D. Okay? We know there's 40 in total. D of them are cats. D of them are dogs. All the rest of them have to be cats. So if we take away D from 40, that'll give us the number of cats. All right, and we'll just skip down here. We'll do one more here. 2 more than triple a number is 17. Okay. So we'll start by saying, let x be the number. Okay. We want 2 more than triple that number. So what operations are we doing here to this number, or this x? Yeah. 3x, so triple means we multiply by 3, and we're doing 2 more, so we add 2. Okay, 3x plus 2. Now, what do we do with this is over here? If 3x plus 2 is 17, what does that is represent? An equal sign. Yeah, that's telling us that this is equal to 17. So these ones up here were just expressions. Now we've got an equation. And this is an equation we could solve to figure out the value for x here. Okay? We'll do the last one here. 2 consecutive numbers add to 27. Again, we'll start off with let x be one number. If these are 2 consecutive numbers, this is things like 2 and 3 are consecutive, 3 and 4 are consecutive, 4 and 5 are consecutive. These are right after each other. Okay. Go ahead. Okay, so what would be the second number? Let x be one number. Okay. If I want to go from one of these numbers to the next number, what do I have to do? What do you think, Abby? Yeah. Okay, so our second number is going to be x plus 1. Right. Now, what do we know about these 2 numbers? We know that they add to 27. So if these things add to 27, we're going to take our one number, x, add it to our second number, x plus 1. And I know that if these 2 things add to 27, this has to be equal to 27. Okay? One number plus the second number equals 27. Okay. All right, and we will stop there. Save.